Alright, what's up, guys? Today, we'll complete this goal with Python. So, suppose a bank has many customers who apply for car loans, alright? And the bank decide whether to approve or reject the customer according to their credit score and their annual income. And this is a training data set with approved it's 0. Oh wait, actually wait. So with 0 being rejected and 1 being approved, and we need to write a program that will predict whether that given the credit score and the income, will this person be accepted or not? So after we run the code, we'll get 1111, which means all 3 of them will indeed get approved for the loan. And so we will use something called logistic regression, which is basically, let me show it. So logistic regression have a major difference between linear regression, which is that logistic regression, it only have 2 outcomes. It can be 0 and 1, 2 and 3, yes and no, etc. So if we draw a diagram, and this is all the data point, alright. So linear regression will draw a line and predict the y-axis given the x-axis. However, logistic regression will find the outcome given the x and y axis. So maybe if it's in this shaded area, they will get rejected. If in this area, they will get approved. It's a pretty bad drawing, I would say, but yeah, that's a fundamental idea with logistic regression. And let's save it. So we'll start the code. I will use a new file and then save us. Yeah, video. I cannot make any name up. So this will be the data, and I got this from my computer science class. I hope that's allowed. So yeah, let's see. First, we'll create a df with data frame. pd.dataframe. So we will use a few library, which is NumPy, which is a array library, matplotlib, a graph library, pandas, a library that deal with all the data organization, and most importantly, the logistic regression. So, and we'll use customer. This should, wait, I don't think this is correct. Wait, is it? It shouldn't be correct. Print df. I think it's correct, but they don't have. Hey, we do have a column. Okay, that's really good. So we will divide the. But first we need to do this logistic regression, or I would say LR equal to logistic logistic regression. Alright, so this should be correct. Yep, it is. And now we have an X, which will be DF credit scores and annual income. So in data, what is happening? So in data, like machine learning, I would say, and especially in the part of predicting, we need two things. One, it's a training data set, which is the X and the Y, which Y will equal to DF approved. So there will be something called a training data set and a testing data set. And testing data set is it's like a brand new data set we need to use to see the accuracy of the program. And a training data set is usually in like few parts. First, it's the data, right? We need the input, but then in a training data set, usually the output is given. So our computer can look at the input and look at the output and see if the output like match whether what the computer predicts it. And so it's like this. We will give in the input, and then it'll give us an output. And if the output does not match, I don't really think I'm good at writing with my mouse. Then it will fix, like it will change its algorithm. And I mean, this would be like a lot more deeper stuff. But this is just the most simple. Basically, it's like the second layer of a linear regression, just making a line. But when you get into like the harder stuff and more advanced stuff, such as neural network, it'll get a lot more complex with a lot more like algorithm, I would say. But this, we're just trying to find, with linear regression, we're just trying to find the x-axis and no, it's called the slope and the y-intercept. Yeah. And now so this we divide it into this whole thing is a training data set, but this it's an output, this is an input. And now we'll do something called lr.fit, and we'll give in the training data set. 希望你能不能小声点儿？你这样干嘛呀？ And wait, where's the new customer? I didn't get that in. So this is the testing data set, which is the stuff that we want to see whether if it's like our program is like reliable enough to be put in the real world, but this is just like a sample. I will put the data in the description section so you guys can use it if you want to. And then we'll do something called df. So new df equal to pd dot data frame new customer. And now we will just pretty sure it's predict. Wait. So I'm gonna print lr dot predict the new df. And I think that's basically the end of the program. Should work. What? Line 31. So you don't. What? Wait. Oh, we need to pull down 2 bracket for this. Yeah, so now we got our result, which is correct with what we got before, according to my computer class. So I would not really get deep into it, but I will probably post a video about like the deeper stuff later. So first of all, these is the libraries we imported. This is the data we need, the training data, and this is the testing data. Or sometimes you can use this thing called train test split, which you just need to give it a data set and it will like just automatically split the train and the testing data and give you the accuracy. But this is like a bit more advanced, and I will do that like later. So first we defined this pandas.data frame. So basically this is just a better format for our computer to recognize the data and train their model. And then this is basically where we used the model and we called it LR. And then we split it, the training data, into 2 parts. The part where it's like the input and the part where it's the expected output. So this is basically like the gist of machine learning, where you need to find the correct algorithm to fit in the expected value. And after that, we created a new data frame for our new customer, which is our prediction data set. And we just use this really simple sentence, which is using our model to predict the new DF. And yeah, that's basically like the meaning of each command. It's not really that hard, but when you look deeper into it, you would like understand how much like effort it just in these 30 something lines of code. And all right, bye. So we learned logistic regression today.